today we are going to revisit net ionic equations, and we're going to learn how to draw what's happening during a ionic reaction. So the first thing we want to do is we've got our chemical equation here, and what we have is we have potassium hydroxide reacting with silver nitrate, and that produces potassium nitrate and silver hydroxide. So we already have the equation, and this one just happens to already be balanced. So we don't need to do any of that, but now we need to include the states of matter. So remember, for this double replacement reaction, both of our reactants are going to be aqueous. And then let's check the solubility rules of our products. So the first product here is potassium nitrate. And potassium is an alkali metal, which is soluble with no exceptions. So that tells us it's aqueous. Or we could look at the nitrate, and the nitrate is also soluble with no exceptions. So potassium nitrate is an aqueous product. Let's take a look at the other one. So this one is silver hydroxide. The rules for hydroxides are insoluble except ammonium, alkali metals, calcium, strontium, and barium. Because silver is none of those, that will be our insoluble product, which is our precipitate, which we mark with an S. So now let's do our net ionic equation. So for our net ionic equation, what I like to do is put in my products my precipitate, which is silver hydroxide, and we also still do our state of matter there. And now from each of our reactants, what ion is it that goes into our precipitate? So that would be the hydroxide. We want to have the OH plus its charge as well as its state that it's aqueous. And from our second compound, it's the silver. Silver is +1 and it's aqueous. Now our spectator ions are going to be our ions that did not participate in order to make our precipitate. So out of potassium hydroxide, that's potassium. And out of our silver nitrate, that's the nitrate. Now let's draw a model of what's happening. So what happens when we put a solid potassium hydroxide in a beaker of water is it breaks apart into the ions. And the ions it breaks apart into are potassium and hydroxide. Now what's important when we draw them is that we draw them in the correct ratios. So because potassium hydroxide has 1 potassium for every 1 hydroxide, we want to make sure that's what we draw in the beaker. For the next one, we're going to have silver and nitrate as our ions in the beaker. Now, if in a different example, you had 2 nitrates, then you would write 2 of the NO3s in there. And then what's happening in our final beaker? Well, we're still going to have a solution, but what we have at the bottom is we have a solid precipitate. And that precipitate that we have at the bottom, in this case, is the silver hydroxide. And because it's a solid, that means that we don't write it as ions, we just draw it as clumped together at the bottom. What you should also maybe have is the solid there, just to really emphasize that it's solid. But then we still have these aqueous ions floating around in solution of potassium and nitrate. And again, I want to write those in the proper ratio from our chemical formula. So that's how you draw a net ionic equation. So let's try an example where our ions aren't already balanced. So let's react sodium sulfate with strontium chloride. So this is a double replacement reaction. So our ions are going to switch places. So now sodium will be bonded to chloride. And because sodium is +1 and chloride is -1, our first product is going to be NaCl. For our other product, we're going to now have strontium with sulfate, and because strontium is +2 and sulfate is -2, our formula is SrSO4. make sure you're writing your cation before your anion. This equation's not balanced, so let's balance it. So in our sodium sulfate, we have 2 sodiums. I'm going to put a 2 in front of sodium chloride. That gives me 2 chlorides, but I needed 2 chlorides because of my strontium chloride. So now I have a balanced equation. So let's look at our solubility rules. So both of our reactants will always be aqueous. And when we look at our products, the first one is salt. We know that's aqueous. We could check our solubility rules and see that sodium's an alkali metal. It's soluble with no exceptions. And then for our sulfates, sulfates are soluble except lead, silver, calcium, mercury, and strontium. So that is an exception. So that will be our precipitate, our solid, that is forming as the result of our double replacement reaction. For our net ionic equation, we're going to have our precipitate in our products. And let's do the ions that make it up. So from our first reactant, it's going to be the sulfate. And again, we want to make sure we have the charge and the states. From our second, it's our strontium, our charge, and our state. And now for our spectator ions, it's the ones not making the precipitate. That would be sodium and then chlorine. All right, let's draw this. So this one, when I have Na2SO4, because I have 2 sodiums for every sulfate, I want to make sure I draw 2 sodiums and 1 sulfate. For my next beaker, I have 1 strontium for every 2 chloride ions. And in my last beaker, I'm going to draw clumped at the bottom my precipitate, which is SrSO4. I could put that little solid there. And then in my aqueous still is going to be my sodium and my chloride. Now, they're at a 1-to-1 ratio, but in my balanced equation, I have 2 of them. So you can draw 2 for the balancing. And that will do it.